So hi, thanks for all to come. So my name is Jochen, and I'm working as a consultant and also as a software engineer. So I'm talking today about data mesh, and keep in mind that I'm a software engineer. I'm not a data person. That may be important in some of the argumentation I'll give. And let's start with a little story. So it was last year when we were working for a customer and we implemented a software component for an online store that connected the online shop with the fulfillment. And it was an order management system. And then something happened for the very first time in my entire professional career. The backlog went empty. So yeah, we really had an empty backlog, and the reason for that was that the company was going for an international rollout, and we just had to implement it a few emails and websites, and that was done in one sprint or so. And then we could actually do what we wanted. We had the freedom to do what we think was best for the customer. And at the same time, it happened that some data platform guys went around and asked if someone wanted to use their newest toys, like BigQuery, that they were introducing into the company as well. And we also did some analysis before, not that much. We did a lot in Mongo and in Postgres, but we were kind of tired in adding new indices all the time. So we started to publish all our Kafka events we had, our domain events we have in Kafka, and put it into the BigQuery platform. And then we thought about what could we do? We now have time to think about what could we do to improve the customer's experience. And there was one problem in our domain that we were always working on, and that was an issue with no finds. So if a customer orders a t-shirt or some shoes, but the warehouse did not find this very article, we needed to look at other warehouses or even retail stores and look if it's somewhere else available. But in a small percentage of orders, this was not possible. And this led to a cancellation of an order. And we needed to send the customer email. We could not find your article you're really anticipating. We are sorry, here is a €10 voucher. We try better next time. But again, this is something really disappointing for a customer and also for the company who lost revenue. So the order revenues they already had need to be refunded, of course. And we wanted to find out what was the reason for this no-find events, so this, the no-finds. At the time, we thought maybe there is a system issue, maybe we get the stock updates too late, or anything. So what was the reason for this no-finds? Is it a problem in the software, or is it really a problem in the logistics only? And it turned out it was a logistic problem. But again, when looking at the stock changes over time, we noticed that for quite a lot of no-find articles, we saw a positive stock change a few days after the no-find. And the reason for this positive stocks updates was, well, there were returns. So in online shops, probably half of all articles got sent back to the shop, and they will be available again later. And this led us to the discussion: what could we do? We could just wait 1 day or 2 days or probably a week and hope that this no-find article will be available again later. And using BigQuery, it was for the first time possible for us to do this large-scale correlations and join operations. And we found out that, yeah, probably half of all no-finds got an inventory update within 7 days. And also we had all our domain events like orders and no-finds available for the last year. So we looked back for a year and noticed, and we calculated the revenue that we could have saved if we do not send the no-find email directly to the customer, but wait 1 day, 2 days, 7 days. It turned out if we waited 7 days until we sent the no-find event and hoping to get an inventory update in between, we could save half of all orders that we would have canceled. And then we could also correlate it with the amount of order, and it turned out it was something like 100,000 euro per month that we could save simply by doing nothing. And it was totally clear for us that we do nothing else but implementing this very user story on our own. So we didn't even ask managers or so if we want to wait 7 days, it was 7 days at the end, until we sent the no-find event. And this was possible for us because we had all the data knowledge, the domain knowledge available within the team, and some data platforms that helped us to make simple analytics on our own. So why did I tell you this story? This was a moment when data analytics changed the way how we implement software, in how we decide what to implement, actually. And this was kind of a game changer for us in software engineering, and that's the reason why we created this website, Data Mesh Architecture, because all of these principles that we applied here are founded by Data Mesh. Again, when we talk about Data Mesh, we need to look at Zhamak's book, Data Mesh, which was released this year on O'Reilly. And she and all the other writers and speakers about Data Mesh, we had the impressions that they had this data point of view, this data management or data engineering point of view, but not the point of view of software engineers in the domain teams that owns the operational softwares. But again, the principles are excellent. So the principles of Data Mesh is what applied also to us, what we faced. So you really have to read this book. It's the very first place. It's a great book by Zhamak. Oh, it's by the way, we bought this book some time ago, but to be honest, we never really read it completely. And that has changed when we decided to talk to O'Reilly and offered them to translate this book into German. And this is what we did. So we wanted to read this book, and we talked to O'Reilly, hey, we could translate it for you. So we really read the book. So if you want to read a book, just talk with the publisher, say, hey, I offer you to translate it, you get a free copy, and you get some money, and you really read this book. Okay, so Data Mesh. Data Mesh is all about scaling of data teams. And a bold statement is that central data teams fail to scale. So we as software engineers never really talk to data teams in terms of what user stories or what features are the most important based on data you have. So this never happened in the last 15 years. So I'm a professional software engineer. I never talked to data teams. And they never came to us and offered some help, to be honest. And one of the reasons probably is that the most data organizations are centralized. So there's a central data team, a central data platform, a central data lake that handles all data requirements. And the most important data requirements they may get are from marketing and C-level. So managers have demands, requirements for reports, and that is what central data teams usually build, in addition to machine learning, obviously. So, but this is something that doesn't scale for all the other domains that are around that may also have data requirements. And when we look at this architecture, something is quite similar to what we have done in software engineering and software architecture the last years, and it is splitting up monolithic systems or organizations into smaller parts. And the way that works well for us in software engineering is starting with the domains, doing domain-driven design. So I hope you joined the talk earlier from Susanne or yesterday from Nick Thune, who described in detail how to split or separate a large system into smaller domains and subdomains using strategic domain-driven design. When we have this domain with a smaller scope, we align teams. We can call it product teams or stream-aligned teams or domain teams or whatever you like, cross-functional teams. But we always have one team responsible for one subdomain, for one body context. This is the alignment we learn from team topologies, basically. And these teams build systems, and they build isolated systems, independent systems, using architectures like microservices or micro frontends, if you like, or self-contained systems. So the systems they build are aligned to the team structure because of Conway's law. And this is something that works pretty well for us in software engineering. This is how we scale software engineering today. Yeah, and data mesh basically applies all these principles and projects them on data. So all the principles we have seen here are now applied to data, and it allows teams to optimize their domain and their domain data with data analytics. This is what data mesh is about. So data mesh is about decentralizing data so that teams can do data analysis on their own. Okay, how does it work? What is data mesh? And there's no data mesh talk without talking about the four first principles as defined by Schemek. So the very first principle, and the most important, is domain ownership. It is the alignment and the ownership and responsibility of data to a single domain team. So a team that builds the operational software is responsible for the analytical data as well. So it's no more the responsibility of a central data team to set the data that is in a data platform, like a data lake or data warehouse, to be correct. It's the responsibility of the domain teams that also owns the operational systems, that owns the microservices and apps and web frontends. This is a core principle. And all other principles are there to support this principle. So the next principle, data as a product, issues or addresses the issue that if you have domain ownership only, teams would build data silos. And data as a product is a concept that defines interfaces helping to connecting different data from separate domain teams by applying product thinking. So data or data sets are getting treated like an REST API or a feature on a web page. In terms of it needs to be valuable, it needs to provide business value, basically, and it needs to be understandable for other domain teams. When we, again, look at software engineering, we have something like Open API or Swagger applied in recent years. And this is something to come for data as well. So data contracts or data product specifications are yet to be developed. There's no standard yet, but something that is really needed in this domain, so that we can interconnect data from different domains. And the next principle, the self-serve data platform, is there to reduce the effort each domain team needs to build a data product. So a data platform is there that makes it easy to build data as data products using all the principles, all the interfaces that are defined for the data. And you usually have a separate data platform team building a domain-agnostic data platform, and all the services, all the capabilities the data platform provides need to be in self-service. So you really want not to have a waiting condition in there. And the last principle, federated governance, helps to set up rules how the different data products are connected, actually. Okay, once again, data mesh is only scoped on analytical data. So data mesh is no answer for operational data, it's only for analytical data. It's really important to keep in mind. Okay, here I have a data mesh example with me. It's an e-commerce example, and if we look at the lower swim lane, we see different domains that we usually see in e-commerce. In e-commerce, we usually have a customer journey that we build, and we can build it into independent software systems. So it starts here with a product search. We click on a search result, coming to an article detail page, going forward to checkout, fulfillment, and lastly there's payment. And these are the operational systems that we have in our online shop. And this is what we call source-aligned domains, as each of these domains and domain teams generate domain data. And using or adapting the principle of data products now allows us to define data sets that makes these data sets available for ourselves. So that on the top lane, we can build aggregations and more consumer-aligned data products that are relevant for business-specific domains and business-specific needs. For example, we have reporting and KPIs and dashboards that are demanded by the management or the C-level, and we can define a team, like a management support team, that understands this management domain and builds reports that the CEO needs. And the same with marketing, the same with controlling, the same with other business domains. And in the middle, there are aggregations. These are data products that are built based on other products and to be used by consumers. Yeah. So these are not the standard. You may have a data mesh without aggregates, but it may be an optimization to have these in between to minimize redundant efforts. And this leads us to a data mesh architecture. And this is a reference architecture that we came up with. So we have federated governance on top, we have the domains in the middle as they are the central, and we have the platform, the self-serve data platform on the bottom. So let's look deeper into each of these. Let's start with the self-serve data platform. So data mesh is not really a technology thing, but technology is yet important. So data mesh is not a new data technology. It is usually built currently on existing data solutions provided by cloud providers like AWS with S3, like BigQuery from Google, or some specific offers from Snowflake and others. And we use these platforms for storage and for queries, for querying data. And also in data mesh, in terms of discoverability, we need a data catalog, and again here we can use data catalogs available, either from specific vendors or data catalogs that come with the cloud providers. And also we have monitoring, so we want to make sure that the data we provide as data products have the quality we assure. So pretty much the same as we have Datadog for our services. We need some kind of quality security for the data. So what is it? It's regular scheduled queries that make sure that our expectations we defined on data are still in place. So nothing new here from technology perspective. It's just using available platforms. This may change in the future, so maybe we'll see some domain data mesh specific platforms in the future, but they are not yet available. Okay, next look into what a domain team, a software engineering team, needs to do to use a data platform. And let's say we have operational data in our databases and more importantly in our Kafka broker, usually. And what we do is we ingest our operational data and copy it or stream it into an analytical data platform, like in S3 or in BigQuery. And then we mostly have 3 layers with raw data, with some curated and managed and cleaned data and aggregations that are built on the events, the entities, and probably also manual data that's available in the data platform only. To have this cleaning and aggregation in place, the simplest way that you can do, and this again from a software engineering perspective, is to use SQL. We all have learned SQL at school or at university, and we can define SQL queries that clean data that parse JSON and that do aggregations. And what we do with, how can we do it? Well, there are tools available. One of them is dbt, which is really a nice tool for analysts where you can manage the SQL statements you have. And more importantly, you can also define tests, defining the expectations you have for the data. So the data quality can also implement it just like unit tests in a specification. Specification, or you can even write specific SQL statements for your tests where you expect an empty result set for the tests to succeed. This is just one tool available to implement analytical data models. Then the next point is, what can we do with this data we now have in the data platform? And this is data analytics. So we have 2 things that we do with analytical data in our platform. It's analytics and it's data products. We start with analytics, and analytics usually is using the aggregations we have and maybe also the managed data sets we have, and defining questions or hypotheses that we want to understand to get insights, and we use visualization tools for that. Like here it's QuickSight, or you can use Looker or Tableau, whatever you have. They all work pretty much the same way. Also, an alternative, you can use notebooks where you can implement Python code. It's usually Python code, but also can use SQL in a more explorative way. So these are basically the two big environments we use for analysis, for data analysis. And all the cloud providers have support for both. Then the next thing is data products. So if another domain comes up and asks for data from a domain, we build data products. And a data product, in our definition at least, is a data set that has metadata, that has semantic and syntax descriptions. So it makes it understandable for other domains and gives them guarantees and information about the domain owner and the update frequency and so on. So think of it like Swagger or OpenAPI for data. This is what it is. And also, a data product is not only a data set, but it's a managed data set. So the team that provides the data product is responsible for the correctness, for the data quality of the data, for the usages, getting alerted when there are problems around. Okay. If you want, you can define a data product in a collaborative way. So we created a canvas, a data product canvas, which you can plot. And you usually start from the use case or some needs you have, and have a way to collaboratively define the output port. So do you need some information as files or tables or dashboards? And what are the input ports? So where does this data come from? So we can use it from the website. Okay, and this leads us to, once again, to the mesh actually. So connecting data product is when the mesh emerges. This is the mesh aspect of data mesh. Using and combining data products from other domains. Next thing is federated governance. So federated governance extends data governance or classical data governance in some ways, as we have now new requirements, especially interoperability and understandability of data products. So we need to define standards how data products should look like. What is the syntax? What are the locations of data products that make it easy to use data from other domains? And also documentation. So the hardest thing about using data from other domains is understanding what the data actually means. So the semantics of a field, for example. And we really need good documentation, as we have learned from domain-driven design in bounded context, that many concepts, many principles are very specific to a very domain. So we need a clear documentation what name means. Is it first name, is it first and last name, has a title included, and so on. It's the same with security policy. So we need to make sure that data is accessible only by persons that are allowed to use the data, and to be compliant with privacy regulations and laws, actually. So how can a policy look like? And this is a simple, very, very simple example how policies can look like. It's just a definition of let's say we use CSV files. Please don't, but get the idea. And we store our data in S3 buckets that are managed by our domain team. And we have a simple wiki page that lists all the data products we have. And access control is used using AWS IAM controls. Simple as that. The data mesh governance group is represented by people that are affected by the governance. So the governance is not done by some data stewards or data architects, but from the domain teams and data platform teams that need to implement the policies that are defined. And they are supported by subject matter experts like legal or privacy experts that give requirements that are not defined on their own, that don't come up from their own. But again, there's no head of data or data steward or data architect or something in this group. And the next thing is policy automation. So this is a great idea from Shamak, is to make policy adherence as simple as possible by implementing the policies that are defined as code. Similar to infrastructure as code, we want to define and to make it easy to adhere all the policies that are defined by the data platform. So you don't have to think about applying policies if it's there by default. Okay, next, let's talk about the elephant in the room when we talk about data mesh. And what is the problem with data mesh? So we've heard we are software engineers, developers, and some time ago we were all told that we need to implement software systems as full stack engineers. So we need to learn HTML and JavaScript and Java and the database. Yeah, okay, let's do it. Then we had the clash with operations, change versus stability. Well, thanks to Docker, we could take over the operational part. And as engineers, we are now ready to get called in the middle of the night. Yeah, sure, no problem. Then security guys came up and said that security is not something they can be responsible, but engineers are responsible for security. So now we are full stack DevSec ops, and we integrated SAST and DAST tools in our pipelines, and we get alerted every week by some false positive CVEs, and yeah, but that's our life. Security is important. You can't say no to security, can you? Yes, then the domain-driven design people came up, and product thinking people came up and said, "Hey, engineers, you need to be responsible for the business. You need to understand your domain exactly. You need to understand your customer. Best to talk to your customers." So now we are full stack biz dev SecOps. And now I come and say, "Hey, it's also your job to do." And is that you're responsible for data analytics, and you need to do data analytics on their own, and you provide data products. And yeah, well, wow, is this an overflow? Is it too much? Can we handle it? And to be honest, I don't have an answer for that one. So maybe we need to be full stack biz dev sec data ops to build great products. But keep this in mind that it's really a lot we need to learn to apply all these patterns. And you really need major teams, really need major engineering teams to do all that. So your organization really needs to be ready to apply all these patterns. Well, at least there is some theory around it. Well, not really. I mean, the team topologies guys referred to cognitive load theory, the learning theory by Sveller and Chandler. It's not really the same thing, but we can talk about this, and we can try to minimize the cognitive load that is needed to apply all these stuff, at least what we need for data. And the intrinsic cognitive load or mental load is based on the fundamentals, so the programming language that we need to apply to do our job, to get our jobs done. And to understand the frameworks we have, to understand how DBT works, for example. And this is something where a specific team, an enabling team, can help by going to domain teams and consulting them or helping them to go into the right direction, to show best practices, to give them copy-paste templates they can apply. And also a good choice of technology is kind of relevant. So if you choose the wrong data platform, which is hard to understand for engineers, it's harder to implement the analytical data models, for example. So we want to minimize intrinsic cognitive load, make it as simple as possible to implement data products. Next thing is extraneous cognitive load. So, and this is also a requirement, what we need to apply and now and do to bring our code into production, to bring our data products into production. And we actually want to completely eliminate this kind of cognitive load. And here is an answer that we need a super simple data platform. Meaning, don't use Spark. Okay. Also automate all things as possible. So invest in the data platform teams that they do a lot of automation and policy as code as automated as possible. So we minimize this, we kill this, so we have more working memory available for germane cognitive load, meaning we have more time thinking about the business problems. So this is the thing about cognitive load. And if you really or still want to implement data mesh into your organization, you really should think about establishing an enabling team that helps engineers to learn all the practices, to understand the policies you have, to use the self-serve data platform, and makes it easy for them to build data products for ourselves. And this is the very job of enabling teams. It's like consultants within the company. Okay. So this is about data mesh. If you want to learn more, once again, read the book of Zhamak. If you want to talk about data mesh, you need to read this book. Unfortunately, we already translated it into German, so if you want to read it, you need to translate it to Sweden or something. Have a look at our website, datamesharchitecture.com, where we have this engineering point of view. And there's a great community, so it's datameshlearning.com, where you can join a Slack channel, where there's a podcast, a newsletter available. They now do meetups again, so join this community. It really helps. Okay, one more thing. We develop a fitness test. So if you want to check if data mesh fits for your organization and if you are fit for data mesh, we have a number of questions or aspects defining which you can rate yourself, giving you a hint if data mesh is the right choice for you or if you're not quite ready for data mesh. So if you want, you can click on all these things, and if you want, you can also discuss the results with us. And to discuss if data mesh seems useful for you or you should rather invest in other aspects first. Okay, so that's from me about data mesh. So thank you very much for joining.